Okay, so what I want to talk about today is I want to try and give you guys a deeper understanding of the ratios. Okay, so sine, cosine, tangent. And I wanted to wait till after chapter 7 so that you have kind of a pretty good understanding. And basically this is kind of where we would end your understanding. We'd move on, and yeah, we do use sine and cosine, but kind of conceptually, I don't know if you guys really understand what those ratios are. And it's kind of a bit of a black box when you punch it into a calculator and a number comes out. And so I wanted to kind of start by asking you guys, what is sine, cosine, and tangent? Who can tell me? Just take your best guess at it. David.
A graph.
It's a graph? What do you mean by that?
I think it's of something to do with a circle or something.
Okay, something to do with a circle or something, yes. So that kind of hits the nail on the head for me when I have a guy that is doing quite well in the class and says that trigonometric ratios have something to do with a circle or something. And I'm not picking on him, but it's just further to my point that kind of the understanding is not really there. Like, you guys know what to do when you see the numbers, and you know how to find the angles and the values, but what does it all mean? What does it really mean? Anybody else have a better idea? Come on, some of the...
Fusca?
I'll start picking on some guys. Fusca, you want to give us a definition?
The ratio between sides of a right triangle.
Okay, good. Yeah, so he hit on a few very important things, okay? So it's a ratio, first and foremost. Whether it be sine, cosine, or tangent, very, very good. It's a ratio, okay? That's what those are referring to. And it's a ratio of the sides in a right triangle. It's a very good answer, very good description, okay? Let me ask you this, the next question. Can a sine of any angle be greater than 1? Who thinks, who doesn't know? Just be honest, put up your hand. Okay, who thinks that they can be greater than 1? And they can't be? Okay, so there's about 6 of you guys that think. Anthony, tell us why.
Is it because the sine is opposite over hypotenuse, so the opposite can never be more than 1? Like, if you make it a ratio, it will never be more than 1 of the hypotenuse.
Why? Very, very close. Tristan.
Because the hypotenuse is the longest side, and if you have a
Excellent.
1 ratio, since it's opposite over hypotenuse.
Right.
The
Okay.
opposite can never be
Perfect. That's the exact answer I was looking for. So you can never have a sine that's bigger than 1 because the opposite side can never be bigger than the hypotenuse. Okay, so conceptually, all of you guys should get that right away. You should know right away, okay, sine can never be greater than 1. What about cosine? Yeah?
Same thing.
Yeah, same thing. Definitely can it be greater than 1. What about tangent, Nicholas? Can you have a tangent value of an angle greater than 1?
Yeah.
Why? What's the formula for tangent?
Opposite over adjacent.
Okay, so why could that be greater than 1? Why could this be greater than 1? Why not? If I draw an angle, theta, and I want the opposite side, it's actually pretty close to a 45. Let's do this. Okay, here's my angle theta. Here's my right triangle. Andrew?
Because it's opposite over adjacent, the opposite can be bigger than the adjacent?
Definitely, yes, of course. The opposite side, see how much bigger it is than the adjacent? So this ratio is going to be greater than 1. Okay? So it's important to note that this has to be less than 1. Has to be less than 1. Can be greater than or less than 1. Okay? So as a very, very base understanding, you guys should all get this. Any questions about this so far? No. Okay, so now we're going to get into kind of the meat of what I wanted to show you guys today, and it's called the unit circle. Has anybody heard of the unit circle before? It's a big concept in math. Okay, you have. What have you heard, Dave?
Like it goes 1 centimeter around, like the radius can only be 1 centimeter.
Okay, very good. So the radius, good, doesn't have to be centimeter. It has to be any,
Yeah.
but it's 1, right? So that's very important. So the radius, as we know, is from the center of the circle to the end. So this point here has to be 1, 0. This point here has to be 0, 1. This has to be negative 1, 0. And this has to be 0, negative 1. Okay, that's because my radius, so this line, this line, this line is 1. Everybody understand that?
Yep.
Okay. Now if I draw a line from here to here, let's do 45 is pretty easy to draw, right? Because we're right in the middle of 90. So if I draw this, like this, okay? So this I know, if this is 90, we all understand that that's 90. So we know that this angle here I'm drawing is 45 degrees. Agreed? What's the length of this line? Jude?
1.
Yeah, 1. It's the radius, right? Okay? So everybody understands that no matter what angle I draw from the center, as long as I go from the center to the edge of the outside, or the circle, the edge of the circle, the radius is going to be 1. Everybody okay with that? Okay, so now the next part is I want to create a right angle triangle. Okay? And the reason I do that is because we know that these ratios only apply to right angle triangles. The reason I'm covering this now, in the next section you're going to start to work with triangles that aren't right angles, but for the time being we only know, this is in capitals here, only for right angle triangles. And it's important because later, when you get questions where you don't have right angle triangles, you're going to get very tempted to try and use these ratios because you've gotten used to them and they're very easy. Okay? But it's important to remember that. It's only for right angle triangles. So I've created a right angle triangle here. All right? So now if I try to find the sine, cosine, and tangent of that angle, let's do that. So we go sine 45 degrees is equal to what?
It would be x over 1.
Okay, yeah, so well, O, opposite over hypotenuse, right? And opposite is this value here. So actually we would call that y, right? Because it's a y value, right? Would you guys agree? It's the height here, y. So y over 1, which is just y, right? So sine 45 is equal to the y value of this point. You guys all agree with that? Any questions so far? Okay, so now let's go cosine. Using the same logic, it's adjacent over hypotenuse. Adjacent now is the x value of this point, right? We go x, y, so we have x over 1 is just equal to x. Okay, so cos 45 is x. Any questions there? So now what I've done is I've created kind of an artificial scenario where my sine values are my y values on this chart, and my cosine values are my x values of any point on the circle. You guys understand that? Okay, last one. So tan 45 is going to be equal to my opposite over adjacent, which is opposite is y and adjacent is x. Okay, so there are my three ratios for cosine. Can anybody tell me now, without using their calculator, what is the value of cos 45? or sine 45? So no calculator now. Here's the magic. Tell me. Nobody? No? Like not exactly, but can you guess? Can you get close? Bro?
About half.
Okay, how'd you get that?
Well, the y value is going to be about half of 1.
Good. Actually, if you do look at it, you're very good. That's what I wanted you to do. It's not really half though, right? It's more like, what would you say?
70.
Yeah, or 75.75, right? Somebody do it now? What's sine 45?
170.
0.70. Okay, so look, 0. Is it 71?
7-1 there.
Yeah. Okay. Even with my really messy, not accurate, no ruler used, look how close we got to 0.7. Would you guys not agree that's pretty darn close, visually speaking? Right? Okay, so now we're gonna try another one. How about cos 45? Josh.
Would it be 70 also? 71?
Very good. And you know that by looking here, right? So here's 0.5, here's 0.5, there's 0.7, right? Maybe it was a little bit drawn too far. Maybe it should have been a bit higher. Okay, but yeah, you get the idea, right? So now tan is going to be what? Tan's not one you can look at on the graph, but you've already have two pieces of information you need now to get tan, Nicholas?
1.
Good. Starting to make sense? A little more? Okay, let's do a few more. So I'm going to try to the best of my ability. Actually, well, let's do this because this is probably easier for me to draw. Let's do 22 and a half. A little bit short, but let's say close enough. 22 and a half. Okay. So there's my angle 22 and a half. I've got that by splitting my 45 in the middle. I look a little bit short, so maybe it should be a bit higher, but anyways, there's my point. Okay. Actually, sorry, before I go on, does it make a difference for these ratios, the size of the triangle?
Because it's a ratio, you can use it for any size.
Right, exactly. So just because I've chosen a triangle with the hypotenuse 1, doesn't mean that all of this doesn't apply. These ratios don't apply if I were to draw the same 45-degree angle. I'm still going to get that same ratio of 0.71, okay? Because now my hypotenuse is bigger, so even though this value is more than 1, so is my hypotenuse, it's more than 1. Okay, so it's important to note that the size of the triangle doesn't matter. And that's why the unit circle works, because it doesn't matter the size of the triangle, because any triangle with these same angles is going to be a similar triangle, so your ratios are all the same. Okay? So the what makes the unit circle really cool is we've chosen a circle with a radius of 1 on purpose just to simplify these things. Okay? So that we know the y-coordinate now is the actual sine value. Alright, so I've drawn this 22.5. I'm going to draw my right angle triangle, drop this down. There's my right angle triangle. So now I'm going to ask Matthew, sine 22.5 off the top of your head. Just take a guess. You don't have to be right on. Okay, so you missed the whole thing then. We're just looking for the y-coordinate. So what's this y-coordinate here, Matthew? If that's 0.5.
Like
Sorry?
2.5?
Yeah, 0.25, or it looks a little higher, maybe 0.3, right? What's the actual value? Yeah,
0.3826.
0.
3826.
Okay, so I did draw this angle a little low. I said that on the beginning, right? Should have been a bit higher. So really it should have been more like that. Okay? And that's just because I have, very crude instruments. Okay, you guys are going to do a much better job than me. So here, this comes down. This is the value now you're looking at. So you guys can see how that's close to 0.38. Yeah, agree?
Yeah.
I would say so. All right, next one, cos 22.5. Jameson.
Would it be the same thing as her?
Sorry?
Would it be the same thing as?
No. Come on, guys. I'm surprised. Both of you guys should have. It's quite simple, right, Mark?
Like 0.94?
Yeah, 0. Well, I don't know. Did you do that on your calculator?
No, I'm just guessing.
You're
That's
going to
really
two,
close
to
that.
2 decimal places? You're that good?
No, so like it's more than 9, but like less than 10.
Yeah, okay. So what is it exactly?
0.92.
Yeah.
0.92. So he's very close.
Yeah, he just calculated.
No, I didn't.
No, I can see where he's coming from, right? He knows if this was divided into points to 10, he said that's a little bit too close to be, yeah, I can see where he's coming from, so he went a bit higher. Okay? So now, 10, 22.5. We don't need the graph for this. How are we going to get that, Josh?
Just use the other two values?
Yep. So you're going to do this divided by this, right? It's sine over cosine. So when you guys get into grade 11, that's going to be one of the first trigonometric, they call it a trigonometric identity that you guys are going to learn. That is equal to that, okay, for any angle. So you can try any angle, you can do tan, it'll be equal to the sine of that angle over the cos of that angle. Okay, and there's the proof right there. All right, if you believe the definition, it's opposite over adjacent, that's enough proof to prove that. Okay, so what's this?
0.4159.
5.9?
Yeah.
Okay. All right, because 2 people got it wrong, we got to do one more. Let's do, so splitting 45, adding 22.5 to 45. Let's say that's 67.5. So might be a little short again, but let's see. Okay. So this angle here now, and I know it's getting confusing, but this is 45 plus 62 is 67.5. Okay, so here's the triangle now we're looking at. This is a right angle triangle, right here. I had another color I draw. Let's just put it in deep. Okay. Alan, sine of 67.5.
I'd say that's about 0.9.
Okay, yeah, close, maybe a little bit less. What is the actual value? Maybe 0.8 something? 0.92?
Oh, you're
yeah.
pretty close there. You're gonna ace this test.
Okay, which makes sense because it's kind of the reciprocal of going this way, right? So those angles are actually related, if you guys can imagine that. Okay? Cos 67.5. This is going to be, is it 38.26?
Yeah.
Yeah, because those angles are related. So now this distance is the same as this distance was before, right? Because they're related. So maybe not the greatest example. But I think you guys get the point. Matthew, do you get it now? Matthew? Yeah? Oh, because when smart guys like that still not quite getting it, I'm concerned. Any other questions about this? Okay, let's try an obtuse angle. All right, so I'm gonna go. I'm gonna say that this is, if this is 22, this is a little less, so I'm gonna say that this is a 20-degree angle. So that makes this angle here what? Good, 160. Okay. So now, David's gonna tell us. Yeah? What's the sine of 160?
About 0.25.
Sorry?
About 0.25.
Okay. What's the actual value? 0.24?
34.
34. Okay, so this is not drawn quite well enough, but this will actually make a lot more sense when you guys actually draw it accurately, right? You use a ruler, you use a protractor. You'll see how close you can actually get. You can actually get to 2 decimal places, believe it or not, just freehanding. Okay, so this distance here then is 0.34, which seems reasonable. Cos 160. Fish.
Like 0.8-ish.
Yeah, it looks it's more, I think, right? It's really close to the line, right?
0.9596.
Right? It's this value. Okay, so what's the actual value? Hold on though, before we actually do the actual value, what is the actual x value of this, Tavish?
Of the
What you just said. You said 0.9, right? Is it 0.9 though? Because x is 0.9 is over here.
point.
Yeah, negative. It should be negative, right? So what's the actual value?
Negative 0.997.
Okay, and now we do 10. We just do 1 over the other. So what's that?
Negative 0.3639.
36 what?
39.
Okay, why do you think this is negative, Spencer? 10.
Because if cosine is negative, then if you're dividing by each other,
Right, it's a negative over a positive, so it's negative, right? I'm going to do 2 more, and hopefully that's enough. Okay, how about this one? We're going to go really, really small. So I'm going to try and draw, and this is 1 degree there. Okay, so this little tiny angle. So my right angle triangle, I drop it down here. I make my right angle triangle. So it's just like a little slither. Okay? Cheesecake when you're on a diet. This angle here then is what?
179?
No?
Oh, it's underneath?
Yeah.
Oh, that would be 181.
Yeah, you guys get that, right? 181? Make sense?
Yeah.
Okay, it's gone just past the x-axis, so it's 181. Okay, so we're in this quadrant now. So sine of 181 is what? This should be pretty easy, right? It's going to be, Jude, you look bored. Sorry? You're sleeping on me? Sine 181. Really? Sorry? 0.01. Okay, good. Positive or negative though? Why negative? Because what?
It's on the other side.
What's the other side? The left side?
Not the bottom.
The bottom. Good. Yeah, because it's down, right? It's the y value. So what's the actual value? 0.02? Okay, so yeah, basically nothing, right? Extremely small. And now cos 181. Matthew? Looking here?
0.10.
-0. Yeah, like 9, right?
999.
Yeah, we're very close to the edge, right? But again, it's important, I want to show you that we're negative again, because we're in this side of the x-axis. And finally, 10, 181 is going to be a small number divided by a big number. Now, what's that? Be really small, right? Tristan, what's that?
0.0200.
0.02, okay. Because you're basically dividing by 1, right? What's important to note though here is 10 again, now it's not negative though, it's positive. Okay, so you have a negative divided by a negative. Alright? Okay, and finally the last quadrant, we'll do one more. Anybody pick an angle in the fourth quadrant?
77.
It's not in the fourth quadrant.
272.
272. Okay, this is 2 degrees because this is 270, right? 272. All right, so this is the last one here. Sine 272. Not using your calculator, looking here. Somebody?
Sine is 1, I think, or around 0.999.
0.999? Positive or negative? Negative 0.99?
Yeah, something like that.
Yeah, I'd agree.
And then cos is about, or cos is
Yeah.
about 0.1.
Negative or positive?
Positive.
Or 0, 1 is pretty small. And then 10 is
Negative 0.99 over 0.01.
right. Negative.
Yeah.
Okay. All right. So we're done. You guys heard of cast? Have you seen this? Cast? You ever seen this? No? Okay. What cast is the initials starting in the fourth quadrant. I know it's kind of weird that we start in the fourth quadrant, but just because cast sounds better than astic. All right? That's why they do it, but it can get confusing. What this means is this is the ratios of when the ratios are positive. Okay? So in the fourth quadrant, the only ratio that's positive is cosine. Okay? And that's because the x values are positive. Okay? The sine values you can see are negative, so sine is definitely not positive. And the tangent values are going to be negative because the sine value is negative and the cosine value is positive. So it's a negative divided by a positive. Okay? A stands for all. So in the first quadrant, every ratio is positive. Cos is positive.